Hi everyone. Today's topic is essential problem solving, analysis of Eulerian circuits in multigraphs. My name is B. Saicharan. I am from Data Science Department. Today's topic Eulerian circuits in multigraphs. Agenda introduction. First of all, first topic introduction to Eulerian circuits. Understanding multigraphs. How to understand in multigraphs. Conditions for Eulerian circuits. Which condition is applicable for Eulerian circuits? Algorithms for finding Eulerian circuits. Which algorithm used to find Eulerian circuits is that one. Applications for Eulerian circuit and also what is applications of Eulerian circuits. Next, challenges in multigraphs. Recent advantages in research. Case studies. Finally, conclusion and keywords. Next. Introduction to Eulerian circuits. First of all of you know Eulerian circuits. In Eulerian circuits means an Eulerian circuit is a closed path in a graph traverses every edge exactly once, returning to the starting vertex. This concept is known as Eulerian circuits. We will see definition of Eulerian circuits. What is the definition? An Eulerian circuit is a closed path in a graph that traverses every edge exactly once, returning to the starting vertex. This concept is in understanding the structure and behavior of graphs. Eulerian circuit means Eulerian circuit is a closed path in a graph that crosses every edge exactly once, a time returning to the starting vertex. Next, importance in graph theory. What is the importance of graph theory? Eulerian circuits are fundamental in graph theory as they provide insights into connectivity and travel properties of graphs, influencing various applications in computer science, logistics, and network designs. Importance of graph theory. These Eulerian circuits are used to find network designs, logistics in computer science, different applications in various applications. Next, understanding multigraphs. How to understand multigraphs? Definition of multigraphs. You can see what is the definition of multigraphs. A multigraph is a defined as a graph that allows multiple edges between the same set of vertices, enabling a more advanced representation of relationships and interactions. What is the examples of multigraphs? We can see examples of multigraphs. Real world examples of multigraphs include transportation networks where multiple routes connect the same locations and social networks where individuals may have multiple types of relationships. Examples of multigraphs in real life is a one Google we can see route maps, how they can provide. Okay, na? Next, properties of Eulerian circuits. What is properties of Eulerian circuits? Necessary and sufficient conditions for a graph that possesses an Eulerian circuit. It must be connected and every vertex must have an even edge, not odd edge, even degree, not odd degree. These conditions ensure that the path can traverse each edge exactly once without retracing. You know what is Eulerian? First in Sina, what is Eulerian? Exactly the traverses edge exactly once without retracing. Okay, next. Euler's theorem. Euler's theorem provides a foundational principle in graph theory, starting that a connected graph as an Eulerian circuit if and only if all vertices have even degrees, establishing a clear criterion for existence. Every graph have even degrees. Even degree means 2. 2 degree only, not 3 degree, the odd degrees. Next. Key findings and future directions. Here see in picture Eulerian circuit example graph. You can see how we have vertices and edges. Summary of insights. Analysis of Eulerian circuits in multigraphs reveals critical insights into the properties, applications, and the challenges faced in real-world scenarios. This summary of insights, we can see real-world scenarios in our daily life. Second one, potential areas for further research. Future research could explore the development of more efficient algorithms, the application of Eulerian circuits in dynamic networks, and their implications of emerging fields. Potential area for further research. Once again, see this one summary of insights. The analysis of Eulerian circuits in multigraphs. Multigraphs means both graphs reveals critical insights into their properties. Applications. You can see previous slide what is applications are in real world scenarios and the challenges faced in real world scenarios. Next, potential areas for further research. Further research could explore the development of more efficient algorithms, the application of Eulerian circuits in dynamic networks, and their implications in emerging fields. Applications we can see other slide. What is applications? Now we see the one. Next conclusion. We can conclude that what is Euler graphs. Recap of key points. We will revisit main points discussed main points discussed throughout the presentation, reinforcing the significance of Eulerian circuits. Eulerian circuits in both theory and practice. Euler's theorem means a collection of mathematical theorems named after Leonard Euler. Named after Leonard Euler. This is a scientist name. Okay. Next, what is Euler's theorem? You know, you see what is Euler's theorem. Importance of Eulerian circuits. We can see what is the importance of Eulerian circuits. This is very important. What is importance of Eulerian circuits? You know what is of importance? The importance of Eulerian circuits extends behind theoretical interest. What theoretical interest? They have practical applications. Euler's theorem states that for any integer a and positive integer n such that a is a coprime. What a is a coprime to n. A is a coprime to n and is the number positive less than or equal to n that are coprime to n. Then Euler's theorem is known as Euler's theorem. Euler's, if A and N are relatively prime with A less than N, they, if we multiply A with itself items and divide the result by n. The remainder will be 1. The theorem generalizes Format's theorem. Okay. It is important to the RSA algorithm. It is important to RS algorithm. A graph is a balanced if for every vertex, the number of incoming edges equal to the number of outcoming edges. Incoming edges equals to the number of outcoming edges. A connected graph is a Eulerian if and only if each of its vertices is balanced. What if vertices is balanced? Impact various fields from logistics, urban planning. Okay, na children? Thank you.